Yeah, so, and you get a whole number. So essentially, whenever something is divisible by something else, you have to, when you divide it by something, when you divide it by that number, you have to get a whole number. And you see these are both whole numbers. So 15 is divisible by 5 and 3. And one way to figure out whether a number is divisible by another number is just to, you can just see, okay, you can just divide it out manually. But there are some special divisibility tricks, which can be much faster. So for 2, it's pretty easy. All you have to do is the last digit has to be even. So 362 is divisible by 2, since the last digit is a 2, and 2 is even. And for 435, the last digit is a 5, and 5 is not even. So that means 435 is not divisible by 2. So this doesn't work. So are there any questions for the divisibility trick for 2?
No.
Okay, so now let's move on to some harder divisibility tricks. For 3, we must have the sum of the digits be divisible by 3. So for 365, for example, 3 plus 6 plus 5, the sum of the digits is 14, right? And you can either say, okay, 14 is not divisible by 3. So that means that 365 is not divisible by 3. Or another thing you can do is you can say, okay, 1 plus 4 is 5, and 5 is not divisible by 3. So this is also not divisible by 3. So one strategy is just to add the numbers and see directly if that number is divisible by 3. Or another thing you can do is you can add the numbers, and then you can, whatever value you get, you can add the digits of that number. And then you can get this value, which is not divisible by 3. Let's try this strategy on one more example. For 972, 9 plus 7 plus 2 is 18. And from here you can see, okay, 18 is divisible by 3. Or if you want, sometimes it will be helpful to go even further. We can do 1 plus 8 is 9, and 9 is 3 times 3. So we can see that 972 is divisible by 3 in both ways. So we could have just ended here. We could just do no more, and we know, okay, 18 is divisible, so we're done. Or we could have gone further. Maybe it was something larger than 18, so maybe it'll be easier to add the digits again. So we can add the digits again to get that 9 is divisible by 3. So are there any questions on this for 3? And if you have any questions, can you please send a message to let me just change my name. Don't send it to iPad, send it to Sohil Rati. You see the person, send any questions you have. You can either unmute yourself, ask it publicly, or you can send a private message to Sohil Rati. You can choose if you have any questions. Okay, let's move on to 4. To be divisible by 4, the last 2 digits have to be divisible by 4. So for 2947, for example, in order for 2947 to be divisible by 4, 47 has to be divisible by 4. But then you can see, okay, 47, we know that 40 is 4 times 10. Or there's actually an easier way to do it. So 47, we can subtract off multiples of 4. So we can see, okay, 40, yes, we know 40 is a multiple of 4, right? It's 4 times 10. Now we're left with 7. Now we can subtract 4. Of course, it's just 4 times 1. Get 3. And is 3 divisible by 4? No. Since 3 is not divisible by 4, 2947 isn't either. So let's just try another example. Somebody asked, can you send it something? Yeah, the recording of this will be available, so you can always review it if necessary.
I still don't exactly understand how you did that one.
For 4?
Yeah.
Yeah, let me just explain another example. Maybe that will make it more clear.
Okay.
So you have this, let's say, look at this number, 10764. So when will 10764 be divisible by 4? When 64 is divisible by 4. So basically, if you have some really large number, all you really care about is the last 2 digits. You can ignore everything else.
Okay.
So you can just be like, okay, this doesn't matter. We don't care about 107. You only look at 64. That's it. And now is 64 divisible by 4? Now we're going to do like another part of the problem. Now we can find 64. What is 64 divisible by 4? And in order to find whether this is true, you can subtract off multiples of 4.
So basically, you mean we could.
Come here.
Oh.
So you can basically say, okay, 64. Is 64 going to be divisible by 4? Well, without even doing this method, if you already know this is 4 times 16, you didn't even have to do this. But then this may not always be obvious. Oh, we may not know directly that 64 will always be divisible by 4. So easy way to do this, a quick trick, is you can just be that you can just subtract multiples of 4. So we know that we can subtract 40, and then we can subtract 24 since it's 4 times 6, and we get 0. So that's basically it. You didn't even have to do this step. You could just be like 24, and 24, is it divisible by 4?
Yeah.
Yeah, so since 24 is divisible by 4, and 40 is also divisible by 4. Remember what we subtracted off. That means 64 is divisible by 4, right? And if 64 is divisible by 4, then so is 10764, our original number.
Okay.
So this is divisible by 4. So are there any
It's
questions?
kind of like dividing, but not exactly dividing.
Yeah, you could, if you want, this is also another way. You could just be 64 divided by 4 and you get 16. And you see, yes, there's no remainder, so it's divisible. That's another way you can do it if this is confusing to you.
Okay.
So don't worry too much about this part. Just remember the main idea is you look at the last 2 digits. That's all. The other digits don't matter. So are there any questions on this trick for 4?
No.
Okay, so now for 5. For 5, what you do is you look at the last digit. So again, 375, is it divisible by 5? Well, the last digit is 5, so it is divisible by 5. 140, the last digit is 0, so it is divisible by 5. So are there any questions on that trick? And again, these 2 digits don't matter. Oh, never, they don't matter. Just look at the last digit. If it's 0 or 5, it's divisible. If it isn't, if it's like 1, 3, 9, or whatever it is, that's not 0 or 5, it isn't divisible. So are there any questions on that trick?
No.
So it doesn't, okay, yeah, let's move on. Now 6, now we're gonna do for 6. And for 6, all we really do is you check, is it by 2? Is it by 3? And then we say, okay, yes, it is. So if it's divisible by both, remember the key word is both, has to be divisible by both 2 and 3. So let's make sure you remember.
Oh.
If it's, let's say, divisible by 2, but then not 3, then it won't be divisible by 6. Because then it's not divisible by 3. It has to be a multiple of 6. It has to be a multiple of both 2 and 3, or divisible by them.
But then I have a question or a comment. I'm not sure. So is the first one 196 correct? Because it's divided by 2 and by 3.
Yeah, we're going to do that example right now. So as you can see here, the last digit is 6. So of course, it's even or divisible by 2, of course, right? So it's going to be, for the 2, yes, we're good on that. But 3. And does anyone know the divisibility trick for 3? Remember from the previous page?
You add all the digits and see if it's divisible by 3.
Yeah, exactly. So 1 plus 9 plus 6 is 16. And then you can add the digits again. 1 plus 6 is 7. And 7 is not divisible by 3. And so if it's divisible by 2, but not 3, is it divisible by 6?
Nope.
Yeah, exactly. It's not true because it has to be both 2 and 3, not just one of them. And somebody asked how will I get the recordings? I will email them to you later. Okay, now let's try 252. So of course it's even since we have a 2 at the end. Remember, if it's the last digit is 2, 4, 6, or 8, it's going to be, or 0, it's going to be an even number or divisible by 2. So 252 is, of course, divisible by 2. And what about for 3? 2 plus 5 plus 2 is 9. 9 is divisible by 3. So that means it is divisible by 6. Because it's divisible by both 2 and 3. So are there any questions for divisibility trick for 6?
No.
Okay, let's try 8 then. So 8 is again very similar to 4. You know how in 4 we just looked at the last digits? 8 is very similar. Instead of looking at the last 2 digits, we look at the last 3 digits. So 8, 2, 4. Not just, so we can ignore 3. Now we just look at these digits here. So how can we find whether 824 is divisible by 8? Well, one way is that probably the more intuitive way, just divide it by 8. You can do that, you get 103. So you see it is divisible.
Can I say the way you taught us, like just now?
Yeah, just do 824. So you know 800 is divisible by 8, right?
Mm-hmm.
20,
So then that would
800
be,
8 times 100.
yeah.
24, is 24 a multiple of 8 or divisible by 8? Yeah, so it's 8 times 3. So that means this number is divisible by 8. Now let's look at this example. What about 27676? We look at the last 3 digits. And again, one way you can divide it out, or the second way, the quicker way, is you can subtract off multiples. So what's the easy multiple that we can subtract off from 676? And don't worry if you don't understand this way. It's a little bit tricky, so don't worry don't worry if this is a bit tricky, because it can be, as long as you know how to do this way and you can figure that out, that should be enough. But this way can just be a little bit faster, the second way. So as long as you understand the basic tricks and this simple, like just how to divide this like that, should be good. But if you're interested, there's a faster way we can actually do it. And yeah, Justin said that we can subtract 640 because it's 8 times 80.
Are we doing 7 too?
7 it's not really a very good trick, so that's why we're skipping it. There's a really complicated trick for 7, and that's why we're not going to get into it because it's not really needed. We're not gonna cover.
Okay.
We're gonna skip many numbers.
Okay.
We're only covering the important numbers that you need to know. Yeah, and we can subtract 8 times 80, and you get 36. And now what number can we subtract that's easy that we know is multiple of 8? Yeah, 32. And 32 is 8 times 4. And we're left with 4. And 4 is not a multiple of 8. So that means this isn't a multiple of 8, this big number, 27676. Any questions on this trick?
I think we're good.
Let's move on. And 9 is very similar to 3. For 9, all you have to do is see if the sum of the digits is divisible by 9. So for 3798, for example, we do 3 plus 7 plus 9 plus 8. And 3 plus 7 plus 9 plus 8 is, well, you can just add it up, you get 27, right? And the first way is you can be like, okay, 27, yes, it's divisible by 9. It's 9 times 3, in fact. Or the second way, but you can just keep going, you can add them up again. So you can do 2 plus 7, 9. And 9 is, of course, divisible by 9. So either ways, you get that 3798 is divisible by 9. And the other method, or not other method, the other problem that we're going to do with 9 is that 15419. You just add them up, 1 plus 5 plus 4 plus 1 plus 9. So 1 plus 5 plus 4 is 10, plus 10, 1 plus 9 is 10. That's 20. And 20 is not divisible by 9, of course. But the other ways, you can add them up. 2 plus 0 is 2. And 2 is not divisible by 9 either.
Wait,
And
can you explain that one more time?
Yeah, it's just like 3. Remember from 3, we just took the sum of the digits.
Mm-hmm.
We do the same thing essentially.
So you basically just did 1 plus 5 plus 4 plus 1 plus 9.
Yeah. And then we see, okay, is 20 divisible by 9? No. Right? 20 is not divisible by 9.
Yeah.
But another method, just like earlier, if it's 20 is what if it's like too larger than 20? Then you can do sum of digits. 2 plus 0 is 2, and this is also not work. Doesn't work.
Mm-hmm.
And 10 is pretty easy if the last digit is 0. This is 10. This is it. That's a pretty easy trick.
Yeah. Is that it?
That's why there's a couple more, but later. So then everybody, any questions on 9 or 10? So let's move on to 11. For 11, this is probably the hardest divisibility trick. What you do is you calculate the sum of the odd digits and the even digits, and you take the difference of them, but then you just drop the sign. So if it's negative, let's say negative 22, then we can just remove the negative sign. So that's what absolute value means. Just forget about the negative part, only look at the actual number.
I don't understand what you mean by that.
Okay, I'll explain it in example. So I'll get to these 3 examples just to explain it. So let me explain I'll explain the examples first. And we'll see that if this number is divisible by 11, the number is also. And this is of course tricky to understand what it means. So that's why I'll explain it with the 3 examples. So the first example, 1331. Here's what you do. This is the first digit, the second digit, the third, the fourth digit.
Yeah, okay.
So what you do is you take the sum of the odd digits, 1 plus 3. So the odd sum is the sum of 1 and 3, right? Because 1 and 3 are both odd.
Yeah.
And that's 4. The even sum, E, is just E plus 1, which is 4. And then what you do is you take the difference. You take the difference of O and E. 4 minus 4 is 0. And 0, is it divisible by 11? Yes, it is. And just for reference, 0 is divisible by all numbers.
So, like, I have a question. Are we supposed to do only 2 numbers? Because you did 3 plus 1.
Yeah, that's what I say. I just took the sum of, see how we numbered it, 1, 2, 3, 4.
Oh, and could we have done 3 plus 3 also?
No, the reason is that we have 1, 2, and 3, 4, right? And what we do is we have, so what are the odd numbers from 1 through 4? 1 is odd.
1 and 3.
Yeah, exactly. So we look at the first and third digit, and we add them up. Similarly,
Oh, okay.
look at the even digit. So 2 and 4 are even. So you add the second and fourth digit, 3 and 1. And then you take the difference of the sums.
Okay.
Yeah, I'll do some more examples, so hopefully that will clear it up a little bit. So I'm doing 2 more examples here. So now again, let's just say that we number them 1, 2, 3, 4. Right? So the odd ones are 1 and 3. 1 and 3 are odd, right? You find, okay, what's the odd sum? It's going to be the sum of the first and third digit, 6 plus 9. What about the even sum? Sum of the second and fourth digit, because 2 and 4 are easier. 1 plus 3 is 4. And then we do 15 minus 4. Remember, O minus E is 11. And 11 is, of course, divisible by 11. So 6193 is also going to be divisible by 11. So let me explain one last example. 185966.
Wait, in this one, you got, how do you get 1 and 3 for the even numbers?
Oh, that's because we can see here that 1 and 3, because second and fourth digit, right? 2 and 4 even. So you look at the second digit, the fourth digit, 1 and 3.
So in this one, we need to do even?
You just always, whenever you're trying to find whether the number is divisible by 11, you just look at the odd number digits, not the odd digits. You look at the first digit, third digit, the fifth digit, so on, however many numbers there are. Right? You don't care. And after that, you take the even digits, the second digit, fourth digit, sixth digit, however many digits are on your number. You find the even sums and the odd sums. And then you take the difference of them. And you get a number. And then you see, okay, is this number divisible by 11? And then you say yes or no, whatever it is. And that's the same thing for the number. Let me explain one more example, which maybe will clear it up even more. So this is a little bit different example. 1, 2, 3, 4, 5, 6. As you can see, we have 6 and not 4 digits this time. Okay, so what are the odd digits? The odd number digits, remember, not the odd digits, the odd number digits. What are they? What do you put in our sum?
1, 3, and 5.
You don't put 1, 3, and 5. It's the first digit. It is the first, yes, you're right on that part. It's the first, third, and fifth digit. But what is the first digit? It's 1. The third digit is 5.
Yeah.
And the fifth digit is 6.
Okay.
And then what you do is for the even sum, what you do is you do the second digit plus the fourth digit plus the sixth digit. What is the second digit?
8.
Yeah, second digit is 8. The fourth digit is 9. The sixth digit is 6. Now we have 12 minus 23, which is negative 11. And remember, like I said earlier, whenever you have a negative number as a difference, you just do negative 11, and then you just forget about the negative sign. That's it. If you have a negative number.
You have to do all the even numbers. You add all the even numbers together, and then you add all the odd numbers together.
You don't add all the even and odd, but you add all the even number digits. So you add the first digit, like you add the even digits, like the even number digits. You don't add the even digits. You add the second digit because the C2 is even. So the even number digits. Yeah, even position digits. So you have the second digit is going to be the even position digit. The fourth digit is also an even position digit. Sixth digit is the even position digit.
No, that clears everything up.
Yeah, so let me just show here. So the second digit is this. The fourth digit is this. That's what I mean by that. That's why I wrote the 2 under. So, and then again, make sure whenever you have a negative, if you have like negative 11, you just forget about the negative sign. It doesn't matter.
Yeah, okay.
And then is 11 divisible by 11? Yes, it is. So this big number is this one. And that's a lot faster than manually dividing this by 11. So that's the trick here.
Okay.
Let's continue now to 12. And 12, again, is just going to be 3 and 4. Because if it's divisible by both 3 and, remember, and is very important here. It has to be both of them, not just one of them. So let's try 1, 5, 8, 4. Let's find whether it's divisible by 3 first. We find the sum of the digits, 1 plus 5 plus 8 plus 4.
It's 18.
Yeah, it is 18.
And then 4.
And then we can see that, okay, is 18 is divisible by 3, right?
Mm-hmm.
Or another way you could do it is if this was like, you could just do 1 plus 8 is 9. And 9 is also divisible by 3.
Okay.
And for 4, does anyone remember what it is for 4?
Yeah, 4 divided by, 1,584 divided by 4.
Yeah, do you know remember what the divisibility trick is?
The last 2 digits have to be divisible by 4.
Yeah. So
Oh, yeah.
is 84 divisible by 4?
Yes.
Yeah. So one way again is you can just do long division. I'm sure you all can do that. The second way, you can do the method where you subtract. So you can subtract off 80 since 80 is 4 times 20, and you get 4, and 4 is divisible by 4.
Wait, I thought you had to add everything together, but now you're subtracting.
Yeah, adding is for 3. For 3, you add the digits.
Okay.
And if this is confusing the second way, just forget about this. Forget about this way. Don't worry about it too much. So for 4, now we just look at the last 2 digits, right? Now you can just divide it. You can just do 84 divided by 4, And if there's no remainder, then it's divisible by 4. Or this is just a quicker way. You subtract 80, which is a multiple of 4. You get a multiple of 4, and that means it is. For different things, there's different tricks. And yeah, for 3, you add digits. But for 4, you look at the last 2 digits, look at these 2 digits, and then you see, okay, is this divisible by 4? And then see, okay, yes, it is, or no, it isn't. And then you can do that by 2 ways. If you're finding it confusing, don't worry about the second way. Just make sure you can just do manually divide it out. You just do, okay, this is 2, then you can just subtract it out, we get 4, and we can just do that. And we see, okay, there's no remainder, so it's a multiple of 4. So make sure, as long as you can do this way, don't worry about the second method.
Okay.
And remember, we just look at the last 2 digits. Let's try another example to hopefully clear it up. So for 3, what do? 7 plus 9 plus 2. 18. Then.
Then for 4, you do 92 divided by 4, which is it's divisible. So
Yeah. You can do that, or the second method again. You just subtract off 80, and 12 is a multiple of 4. If you're understanding the second method, it can be faster sometimes. So it is, and we're good. Any questions on any of these 2 problems, or this trick, or any of the other tricks before this as well?
Nope.
And yeah, and this means that 792 is going to be divisible by 12. Since we have that 92 is 4 and it's 3, 2, this big number, 792, is also going to be divisible by 12.
Okay, got it.
Let's move on to 15. This is going to be a last trick. So for 15, it has to be both. Somebody asked what is the 11 trick? The 11 trick is you sum the odd number digits and the even number digits. So you sum the first and third digit and whatever, and the even number digits, and then you find the difference of them. Yeah, so this, it would probably be a good idea to review the recording, just in case you forgot anything. So you should watch the video of this class later, so that would make sure you can remember all these tricks.
So are you gonna send this to our parents?
Yeah, I think you can send it to you, yeah, your parents. You should be able to watch it, and then you can watch this video, and you can review all these concepts to make sure you actually know them.
All right.
So as long as you get the basic understanding right now, it's okay. So because you can always review it later.
Okay.
So for 15, it has to be by 3 and by 5. And again, 5 is going to be pretty obvious. You can just do, okay, 5, yes. Right? The last digit is 5, so it's divisible by 5. What about for 3? 4 plus 5 is 9, and 9 is divisible by 3. So that means it is by 15 as well, the big number 405. Now for 4740, it's of course going to be divisible by 5 since the last digit is 0. And then what you can see, okay, let's look at the sum of digits. 5 is a yes, 3 is 4 plus 7 plus 4 is 15. And that's also by 3. So that means in total, this is also going to be divisible by 15. Are there any questions on this trick?
Can you repeat it? The trick?
For 15?
Yeah.
Okay, yeah. So you have to check by 3 and by 5. You get that part, right? You check by 3 and 5 has to be both. Remember, and. Make sure you remember and both of them. And by 5, let's just look at the second example again. Of course, it's going to be by 5. That's pretty obvious since the last digit is 0. By 3, well, you can just sum the digits. Remember the trick for 3, you just do 4 plus 7 plus 4. And you get 15. Right? So you know that this is also going to work. So that's just the highlights of the trick. Now we're going to explore some harder problems using these divisibility tricks. What number between 121 and, actually before I even move on, any questions on any of the tricks? And yes, you can always review the video later. Okay, now let's look at some problems. What number between 121 and 149 is exactly divisible by both 3 and 5? So if it's exactly divisible by both 3 and 5, it also has to be divisible by 15, right? That was our trick just now. 15 by 3 and 5. So by 3 and 5, by 15. So now all we have to do is find between 121 and 149, what number is going to be divisible by 15? And that's not, there's actually two ways to do this. One way you can do 121 divided by 15. You get 8 with the remainder of 1, right? And then you have 8. And that means that we have 8 times 15 is 120. So 8 times 15 is just barely below this range. We have to from 121 to 149. You have to go from here. So 8 times 15 is just going to be a little bit below, 121. So maybe you can actually increase this. Maybe if you just make it a little bit bigger, it'll fall into our range. So what if you make it 9 times 15? Because it's going to be a little bit more. 9 times 15 is 135. And we can check, okay, yes, 135 is in between 121. We have dot to dot, 135 is in the range between 121 and 149. And that means that 135 works. Any questions on this problem? Let's move on. Find the sum of all the counting numbers less than 25, which are not divisible by 2 or 5. So one way to do this is just to write out all the numbers from 1 to 24. Because less than, remember. So 25 itself isn't included. Okay, so now all we can do is just cross out the numbers that are multiples of 2 and 5. And if you have to go, that's okay. You can review the recording later. So what numbers are multiples of 2, or divisible by 2? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Right? Those are all the numbers divisible by 2. What about 5? 5, 10, well, we already crossed out 10, 15, 20, and yeah, that's it. And now all you have to do is add the numbers. 1 plus 3, 7, plus 9, plus 11, 13, plus 17, plus 19. Yeah, okay, so let's see what from here. So now what we can do from here, you can just add them all up. And there's a clever way to do this. 1 plus 19 is 20. 3 plus 17 is also 20. 7 plus is also 20. 9 plus 11 is 20. And then we have 21 plus 23 is just 44. Now, what's 20 times 4? 80. 20 plus 20 plus 20 plus 20 plus 44 is 124. There's actually a fast way to do this, and if we have time, I'll get to it. If not, we won't have. If you don't have time, I might not get to this method. So that's how you. Are there any questions on this method to solve this problem? This is just the reducing law, crossing them out. There's a faster method that uses some harder techniques, but I may talk about it later.
I have to go.
Okay, let's move on. A7, A8. How can we do this problem? Let's just do A. Just look at the sum of the digits, right? So you do A plus 7 plus A plus 8, which is 2A plus 15. Is 2A plus 15 going to be, when will 2A plus 15 be a multiple of 9? Okay, so what are the possible multiples of 9? 9, 18, 27, 36, 45, and dot dot dot. So now what can we do from here? So of course 9 is impossible because we already have 15, so that would mean A is negative, and that's not allowed. Is 18 possible? Let's see. Can 2A plus 15 be equal to 18? If this was true, then we'd have, we can subtract 15 from both sides. This would mean that 2A has to be equal to 3. But A is a whole number. And that means that this 2A is even, right? It has to be, since A is integer or a whole number. But can an even number be equal to 3, which is an odd number? No, so this doesn't work. Now we try the next option. 18 doesn't work either. What about 27? 2A plus 15 equals 27. This means 2A is 27 minus 15, or 12. And we can divide by 2 to both sides, and we get A is 6. And now a good thing that you should always get a habit into is checking if it all actually works. 6, 7, 6, 8. Is this actually a multiple of 9? Well, we can just check that using the divisibility trick. Let's see. 6 plus 7, 6 plus 8. What does it give us? 27. And 27, we can add the digits again. 2 plus 7 is 9. And 9 is indeed a multiple of 9. So that means 6, 7, 6, 8 is the correct number. So 6 is the correct answer. So that's a good way to make sure you didn't make a mistake in your work. So that's a good checking habit that you should always do. Let's move. Are there any questions? Let's move on. A4, 237B. 73B, sorry. It's a 6-digit number in which A and B are digits, and the number is divisible by 72 without any remainder. Find A and B. So what does it mean for a number to be divisible by 72? This means it has to be divisible by both 8 and 9. So when will it be divisible by 8? These digits have to be a multiple of 8. When will this happen? Well, when if B is 0? If B is 0, then if B is 0, let me explain it more clearly. We don't know what 73 something is. Plus some value B, this has to be a multiple of 9. Right? This has to be a multiple of 9 in order for it to work. When will this be a multiple of 9? We can do that when divide 730 by 9, or you can just use the divisibility trick. We can just anyway, you can do anything. You can just find the remainder when 730 is divided by 8, sorry, not 9. And we can just divide that out by manually, or we can do the different method. So now what can we do from here? Now we know that 730 we have to make it a multiple of 8. So how can we somehow put it a multiple of 8? So we have something 640 plus 90 plus b. When will this be a multiple of 8? That's only possible. That's only going to be possible when b is 6. B has to be 6. In order for this to be a multiple of, yeah, b has to be 6 in order for it to be a multiple of 9. So let me just explain that again. So b has to be 6. Since 736 is a multiple of 8, right? It has to be a multiple of 8. This number. It is a multiple of 8. So that means b is 6. Now what about a? How can we find the value of a? It has to be divisible by 9. So we can just sum the digits. A plus 4 plus 2, 7 plus 3 plus 6, which is a plus 6 plus 10 plus 6, a plus 22. And this will be divisible by 9 if a is 5. So a is 5, b is 6. Any questions? Let's move on. 5a4 and 6b9 are 3-digit integers. 6b9 is 5a4 plus 125, and 6b9 is also divisible by 9. Find the value of a. Okay, let's see what 6b9 is. When will 6b9 be divisible by 9? When 6 plus b plus 9 is divisible by 9. 15 plus b has to be divisible by 9. When will this happen? Right, so the possibilities are this either has to be 9, 18, 27, etc. It can't be 9, right? That's of course obvious because it's already 15. It can't be 18. Let me explain why. 50, actually it can be 18, sorry. It can be 18. It can be 18 when b is 3. And we can subtract 15. And we get b is 3. 18 minus 15 are 3. So b has to be 3. Now how can we find the value of a? So now we have 6, b is 3, so 639 is equal to 5a4 and 125. This means 5a4 is 639 minus 125. And what is 639 minus 125? That's just 514. This is 514. And then we can see that, okay, if 5a4 is 514, what is a?
One.
Yeah. Any questions? Okay, so now we're going to look at this problem. Actually, we're going to skip this problem for now because it's a little bit more tricky. We're going to skip these two problems and we're going to go to this problem. Hannah gives clues about her 6-digit secret number. It is the same if you read it from right to left. It's a multiple of 9. And if you cross off the first and last digits, the only prime factor, the remaining number, is 11. So the main condition here is clue 2. The number, sorry, not clue 2, clue 1. Clue 1. It's the same when you read it right to left. And this number is actually called a palindrome. So an example is like, let's say you have 121. If you read it from left to right, it's 121. If you read it from right to left, it's one also 1 2 1. And then some bigger palindromes are 1 2 3 2 1. If you read it from left to right, it's 1 2 3 2 1. Just go into order. But if you read it right to left, it's going to be 1 2 3 2 1, which is the same. That's what it means. It's also known as a palindrome. So the key thing to notice is if it reads the same left and right, so it's a 6-digit number. It has to be of the form A, B, C, C, B, A. Right? Because it has to be the same left and right. So that means these 2 digits have to be the same. These 2 digits have to be the same in order for it to read the same left and right. And these 2 digits. And not all numbers have this form, if that was unclear, like 13. If you read it left to right, it's 13, 1 3. But right to left, it's 31, 31. So it's not always true. It's only true for some numbers. And that means you have to have those digits can be equal. So that's what you must have. And we're given some multiple of 9. We'll deal with that later. Let's look at clue 3 now. What does clue 3 give us? Cross off the first and last digit. And BCCB, the only prime factor, somebody asked, what if you have 33? For what? Yeah, it's AA. You cross those 2 out. What do you mean by if you have 3 3 or 3 3 3? Yeah, no. If it's oh, I see. If we're saying like, okay, what if these are equal? It's still going to be A B C C B A. It's just that B and C are going to be equal now. And yeah, sure, we can have like 1 1 1 1, for example. It would still be A B B A, except A is 1 and B is 1. They can be the same. They don't have to be different necessarily. It's just that we know as a fact that these 2 have to be equal and these 2 have to be equal. Always. Let's resume here. So BCCB, the only prime factor is 11. And that means it has to be only 11. So it can be 11, 11 to the power of 2, 11 to the power of 3, so on. It can't be 11 since that's not 4 digits. 11 squared is 3 digits, so it can't be that either. 11 cubed, well, we'll just do 11 squared times 11. That gives us 1331. And 1331, we see, oh, yeah, so it is 4 digits. So that means it has to be like this. So that means B is 1, C is 3. Okay, so if B is 1, C is 3, and we have something now we know it's going to be like A, 1, 3, 3, 1, A. It has to be a multiple of 9. That means A plus 1 plus 3 plus 3 plus 1 plus A has to be multiple of 9, which means that 2A plus 8 has to be a multiple of 9. And when will 2A plus 8 be multiple of 9? Well, what are the possibilities? It can be 9 or 18, 9, 18, or 27, or so on. It can't be 9, right? Because if it was 9, then that would mean that 2A plus 8 is, let me erase this. If 2A plus 8 is equal to 9, that would mean that 2A is 1. And again, that's not possible since 2A is even, but 1 is odd. The other possibility is 2A plus 8 is 18. That means that 2A is 18 minus 8, or 10, or A is 10 divided by 2, or 5.
Is it time to go now?
You can go if you want, but I'm going to finish it for today.
Okay.
You can also, if you have to go, you can go. Then you can watch the recording when you have time to watch it.
Okay. Who are you going to send the recording to?
Whoever's email address you put, so either your parents or your email addresses, whoever, but you should get it.
Okay.
So A is 5. So that means the 6-digit number is 513315. Carl spent exactly $1 for some 5-cent and 13-cent stamps. How many 5-cent stamps did he buy? Somebody asked 234 432 also works. 234 432, that doesn't work because if you cross out these digits, 33443 does not have has other prime factors besides 11. Even though it's divisible by 11, let's just prime factors this really quickly. So you can just divide it by 11. So just divide it by 11, you can get an answer. It's going to be 313 times 11. And then, and 313 is not composed of only 11. So 234 432 doesn't work, actually. This is the only answer. Because it has to be only 11. So it has to be 11 squared, 11 cubed. You cannot have like 3 or 5 or all that in it. Okay, so so let me try this problem now. Let's try this problem. $1 for 5 cents and 13 cents. So feel free to go if you want to, but I will be finishing this if you want to stick around. So 5 cent and 13 cent stamps. So how can we do this? Well, just say, okay, has to be at least some. There has to be at least one. Let's just try some values. It can be 1 13 stamp. Can have 2 13 stamps. 3, 4, 5, etc. So the key thing to notice here is all you have to do is really do, okay, 100 total cents, since $1 is 100 cents. If there's 1 13 cent, then there has to be 87. And is 87 divisible by 5? No. And that means 87 can't be formed by 5 cent stamps. So this case doesn't work. Is everyone clear on that? So let's move on. So if there's 2 13 stamps, 100 minus 2 times 13, or 26, 74. And 74 is not divisible by 5 either. So this also doesn't work. And I'll actually just, for sake of time, I'll just quickly go through these last examples. If you're interested, you can see the work here. So all I really did is I just say, okay, these both don't work. Since I subtracted 3 multiples of 13, 4 multiples of 13, and they're not multiples of 5 at the end. But 13 actually does work. What's 5 times 13? 65. If you subtract 65, we're left with 35. And 35 is indeed a multiple of 5. So that means we can have 7 5 cent stamps. That means the answer is 7. Let's move on to the next last problem now. These problems are from MOEMS contest, actual Math Olympiad contest. As I said, these are actual MOEMS problems that came before. So you have 1, 2, 3, 4, 5, 6. You add something, you get a multiple of 25. What do you have to add? This is actually something I didn't include here, but there's a trick for the divisibility rule for 25. And basically, what it means is that in order for a number to be divisible by 25, the last 2 digits have to be 25, 50, 75, or 00. You have to have one of these be the last 2 digits. So what can we add to get it to be like that? The smallest number. Well, you can see that 56 is almost at 75. Almost. It's the closest one that's the smallest value that's just a little bit above 56. The last 2 digits again, because we don't care about those. Exactly, yeah. People are saying 19. That's exactly correct. If you add 19, 75. So 19 is the answer. The reason it's the smallest is because you could have added like 44. You could have added 44, and you would have still gotten a multiple of, 5, but 44 is larger than 19, and you want the smallest number. Any questions? Okay, let's quickly go over the problems that we skipped. And you can leave if you want, but I'll just go over it. And you can always watch the video. A 4-digit number is written on a piece of paper. Ashley spills whiteout on it. And now the last two digits are no longer visible. The number is 86 blank blank. We don't know what these blanks are. The 4-digit number is divisible by 3, 4, and 5. Find the 4-digit number. Okay, so 3, 4, and 5. The last digit has to be 5 or 0, right? That's the 5 trick. What about the last 2 digits? Okay, so if a number is divisible by 4, it's also going to be even, right? A number has to be even, has to be a multiple of 2 to be a multiple of 4. Correct, right? So when can this number be a multiple of 2? If the last digit is 5, let's just say the last digit was 5, then the number isn't even, since the last digit is 5. But if the number isn't even, it can't be a multiple of 4. That's not possible. So that means it can't be 5. This is not possible. It has to be 0. The last digit is 0. What about the second to last digit? We must have 8 plus 6 plus some value. We don't know what it is. Let's just call it x. Or actually, let's not do that. Let's see. What's the smallest multiple of? What are the smallest multiple greater than 86? So the possibilities are 1, since 15, or it can also be 4, since that would make it 18, or it can be 7, since that would make it 21. So 8 plus 6 plus 4, or 8 plus 6 plus 7, or 8 plus 6 plus 1. Those are the possibilities. So now we know that this has to be 1, 4, or 7. We don't know which one. So now the possibilities for the 4-digit number are 8610, 8640, 8670. So now what? Now we just check which of these numbers. It has to be one of these numbers. But now which ones actually work? Only one of them is going to be divisible by 4. And we can look at the last digits of all the numbers. 10 doesn't work. 40 does work, and 70 doesn't work. So 8640 is your answer. Any questions? So the key here is broken down by each piece of information. By the 3, by the 4, and by the 5. Let's try number 7. Digits 1, 2, 3, 4, 5 are each used to write a 5-digit number, A, B, C, D, E. The 3-digit number, ABC, is divisible by 4, BCD by 5, and CDE by 3. Find ABCDE. So let's just draw 5 slots. A, B, C, D, E. So ABCDE, they have to be 1, 2, 3, 4, 5. We have to have all 5. BCD has to be divisible by 5. What does that mean for D? That means that D has to be 5 or 0. D has to either be 5 or 0 in order for this to work. And ABC being a multiple of 4, what does that mean? Well, now that we know that this has to be 5 or 0, we know CDE has to be divisible by 3. So so we have C plus 5 or 0. But again, sorry, I should have mentioned earlier, 0 doesn't work. Yeah, E has to be, it has to be 5. Yeah, E has to be, it says BCD has to be the BCD by 5. So that means D has to be 5 or 0. So it is D, not E. So 0 doesn't work because we can only have 1, 2, 3, or 4, or 5, as you can see in the problem. So D has to be 5. C plus 5 plus 8. When will this be a multiple of 3? It can either be 9. Sorry, not 9. It can be 6, 9, 12, dot, dot, dot. Or it can even be 15 or whatever. So can C plus 5 plus C be 6? If it was 6, this would mean that C plus C is 1. Okay, if C plus C is 1, is that possible? C plus C plus 1 is actually not possible, because that would mean that it has to be 1, 0. That's not allowed. So this can't be 1, 0. This is not going to work. Doesn't work. Another possibility, 9. Can C plus 5 plus E be 9? This means that C plus E has to be 4. Is this possible? Yeah, it can be 1, 3. Like Justin said, it can be 1, 3 or 3, 1 for C and E. But there's actually even more possibilities. What if its sum is 12? That would mean that C plus 5 plus E will be 12. This would mean that C plus E is 12 minus 5 or 7. And when is this possible? It has to be 4 or 3. Right? It can't be 5 or 2, because it can be 5. We already used 5. So it can only be 4, 3, or 3 or 4. So it can be 4, 3, or 3, 4. Now let's look at our last condition, ABC by 4. And again, if it's divisible by 4, it has to also be divisible by 2, right? So what value of C will make ABC divisible by 2? Well, as you can see, all these are odd. This is only easy. 4 is only even one. So that means C has to be 4. Since if C was odd, ABC would be odd, and ABC couldn't be a multiple of 4. So now this means that C has to be 4. This has to be 5. And if this is 4, this has to be 3. Now we can see that the only two numbers that are left, we already used 3, 4, and 5. You have to use them exactly once, used once. So we already used 3, 4, and 5. So this has to either be 1, 2, or 2, 1. And which of these numbers will result in it being a multiple of 12? The correct answer, yeah, it's exactly 2. It has to be 2 and 4. So in order for the last two digits to be a multiple of 4, 14 is not a multiple of 4, but 24 is. And then we have to have 2 and 1. So our answer is just 1, 2, 4, 5, 3. The digits I boxed. That's all for this class. If you have any questions, you can ask. And also, I'll send out the recording for this for next class. And also, I'll also send out a more advanced video that if you want, you can watch. It has some harder problems than this. And if you're interested in more advanced concepts related to divisibility, you can always watch that video. And otherwise, thanks for coming to this class. Bye.